Welcome back to the Super Data Science series on Pyspark, where we're working through building a recommendation algorithm right now is where we left off. We've touched on some examples with working with RDDs and data frames and other data files and data manipulations throughout the series. And now we're going to be working just to continue our recommendation algorithm. As you saw in the last video, we passed in our data file. We're using the example from the Apache Spark in Python from the documentation, just to get a good example of using the Pyspark methods and just becoming more familiar with it in general. So I highly recommend, as always, to experiment with values because we're working with a predefined set, just a simple sample set with our data file. And you can always experiment, change. Feel free to build the algorithm further, and don't hesitate to input specific values or try methods that may break it, but you'll learn from it. So let's continue, which we have our data loaded in. Now we actually want to build the recommendation, and we're going to be using the alternating least squares. If you saw on the documentation, it uses the alternating least squares algorithm. You can find more, again, in the collaborative filtering documentation on the Pyspark or Apache Spark website. Let's jump back into our Jupyter notebook, and you can see what we want to do now is set a ranking of 10. We're going to set a number of iterations of 10 as well. And we're going to set a model, which is going to use the alternating least squares dot train. And we have to pass in our parameters of the rating, rank, and number of iterations. Now, what we want to do as well is to evaluate the model, and we're going to be looking at using our training data. You'll see the lambda function again used, and we're going to be working with our set arrays. But let's work with our test data. It's going to equal ratings.map. Again, you can find the full algorithm and the extended algorithm from the documentation if you see the example on the Apache Spark, the Pyspark example from collaborative filtering. We're going to set P. I'm going to set this to the index of 0, and we're going to set the next one to the index of 1. And we want to set predictions. We're going to want to pass in model.predict all, called off of the test data, in parentheses. We have to call map lambda r, and r the index of 0, and 1 r1 and r2, r1 and r2. What we can do to save some time is I added this for you to take a look at. We have our rates and predictions passed in. We're accessing the predictions here, and we're also defining our mean squared error, which is calling off our rates and predictions. We're mapping it, and again, working through our arrays. And we want to add a print statement so we can see the mean squared error, and we can also save and load the model. Now we're working through this fairly quickly, but it's just to become more familiar. Don't get too focused on the high complex details. If you are, that's fantastic. Again, read through the documentation. This is just to give you an example of a already predefined and pre-built algorithm that comes from working with Pyspark that you can find works right out of the box. It's fantastic. Recommendation systems are crucially important, and just gaining more and more popularity as services are using the data to utilize better offerings, better marketing tools, better customer satisfaction. The more data that you are collecting, the more data that's collected in general, the better services that companies can recommend, or the better products. Again, looking at Amazon, if you buy a product, you will be recommended similar products as well. And if you want to look further into some other algorithms that Pyspark offers, you can see the program under the programming guides. Visit the machine learning section. For other ones, just see the different links as well, and you can just scroll through and see the different types of algorithms. You will also see RDD based, the API guide. Usually when you go back and forth, you'll be working through the documentation, and it's just helpful to have such an organized, well put together presentation, so it'll help you work through your algorithms. And if you want to see the entire algorithm for the recommendation system, you can visit the following link in the Spark GitHub repository. See the examples, the source, main, Python, MLlib, and the recommendation example.py. And you can scroll through and you will see if you download it, you can run it and it will become more familiar to working with it. And if you scroll through the documentation as well, you will see some other examples, the other Python files for Apache Spark for specifically for Pyspark. And if you looked at the test data file, you could see it's very simple, just basically structured data, numerical data, and you can try and change the values to see how your results come up. One great thing is that we're working with this data, and Pyspark does it. We're working with the numerical data, and you have other things within pandas, within scikit-learn, other algorithms that allow these recommendation systems to transform data from, say, you don't have something that's numerical, something that is recommended, or maybe a recommendation off a movie that's very good, or something that's not strictly numerical data. You have things such as one-hot encoding and other methods to transform this data into numerical data, which will allow you to build your recommendation systems. And since we worked through a recommendation algorithm and touched on how to work with data frames and RDDs within Pyspark, you're becoming more familiar with working with it. You will eventually need to deploy algorithms on a cluster. And if you visit the deploying section, you will see the cluster mode overview, and it just will give you a quick diagram of how to analyze or how Spark applications run on a cluster. And this is really where Pyspark shines, is its ability to handle such a large amount of data by using clusters, by using its nodes. So if you have the chance, take a look at the architecture. You can see the cluster managed types, monitoring, which is a huge aspect of watching your data, and you can scroll around, become more familiar with it. But take a look at the main diagram where you have your driver program, your Spark context, your cluster manager, your worker, and your worker nodes. And you can see the diagram, how the data is moving around. I hope that through the tutorials, through this series, that you will be more familiar with Pyspark. If you're not specifically familiar with Pyspark and you see some methods that you're confused about, again, look through the documentation, and also don't be afraid to pull it up in Python, because we are working on Pyspark. It's built on the Python programming language. So you see, all those similarities while we're writing these algorithms and working with these algorithms. And I should have mentioned earlier the actual link, if you didn't catch it, to visit this site. If you're working from our documentation earlier, you were in the MLlib, you can visit the deploying tab up top and select overview. If not, you can visit spark.apache.org/docs/latest/cluster-overview.html. This will bring you to the cluster mode overview that we were discussing with our model. This is more advanced. This is just more complex Pyspark, you can say. We're really focused, through this tutorial, we're really focused on just becoming more familiar with setting up Pyspark for one, running some basic commands, since really in any language or any AI, ML, or data science operation, one of the most crucial elements is just being able to manipulate the data and work with it. So now you can use data frames, you can call on data frames within your data, you can work with RDDs, and you can use the pre-built algorithms that, again, similar to the recommendation model, you can run straight out of the box once you set up Pyspark. It's just much simpler than writing pure Python. It's efficient, easy to use. And as you can see from us working in Pyspark, the benefits that Pyspark has on running large scale and large quantities of data, it's fantastic. It's what makes it such a useful tool for you to be able to deploy when necessary. Overall, I hope you have learned from this series, become more familiar with what we just mentioned, the data frames, RDDs, and these operations within Pyspark. Please pay attention or check back in the future for new series within Pyspark. I'd like to be able to start incorporating some that we will go through creating our own unique algorithm and end up deploying it on a cluster and handling some extremely large quantities of data. So we can really see, how the nodes perform. But, these elements are crucial. You have to be able to work with it first. So the RDDs, the DFs, the passing in of the file, just running SQL commands, just the basic operations are always the foundations that we can build off. So again, please check back in the future. I hope you enjoyed the series. And as a last insight, please subscribe to the SupderDataScience channel, where you will get up-to-date and weekly information. You'll stay informed about what's going on in the industries. There's a lot of exciting and new things coming up in the 2018 year. Also, please feel free to comment, share, and like the video. And I will see you in the next one. Hope you enjoyed it, and have a good one.